When it comes to solving application problems involving systems of equations, there are a lot of problems that you will see that are considered classic system of equation application problems. We're going to go ahead and divide this into two sections, and these first ones that we're going to look at will be best solved using substitution method. So a couple things that we want to know how to do. We want to be able to understand the key terms and phrases and how they translate into mathematical operations. We also want to understand how to solve a system of equations using substitution method. Before you continue with this presentation, I recommend having a highlighter so that you can highlight things as we go through these problems. The biggest problem people have with solving application problems is, of course, knowing how to translate it. And what we're going to do is, just like we've done with every other problem, we're going to break it into individual components. So upon completing this presentation, you will hopefully be able to set up a system of equations to model a real-world application problem involving at least two unknowns. You will be able to solve the system of equations and determine if the solution makes sense in the context of the problem as well as the real world. So our procedure in order to solve application problems using substitution method. The first thing we want to do is read through the problem, identify the unknowns, and assign variables to them. One thing to note is that generally identifying the unknowns, this will be at the very end of the problem. Usually you will be given a bunch of information and then it will say find blah blah blah. The second thing that we want to do is organize the given information. Create a table, draw a picture, write down any relevant formulas, and another thing that you can do is just summarize the statements. Finally, we want to translate to a mathematical model. Note that the number of equations needed is the same as the number of variables or the number of unknowns. Once we have our mathematical model, we want to solve using substitution method. Finally, interpret the results using complete sentences and include correct units. Check your solution in the context of the problem. I don't mean plug it in and check that it works, but just make sure that it makes sense in the context of the real world. If you have a plane that's traveling 50 miles per hour in a 1,000-mile-per-hour wind, that doesn't make sense. All right, so another thing to note is when we have at least two unknowns, you must interpret the results. Simply because there are two answers. You need to identify which one is which. So let's go ahead and look at some problems. Our first problem that we have, it says, the median starting salary of a nursing major exceeds that of a business major by $10,000. Combined, their median starting salaries are $96,000. We want to determine the median starting salaries of business and nursing majors with bachelor's degrees. So the first thing that we want to know is what are we looking for? So our unknowns, we want to know what is the median starting salaries of business and nursing majors. So I'm going to go ahead and start by putting some variables and labeling them. Now, when working with application problems, one of the things that can help is instead of always using X and Y, use variables that identify what you're looking at. So let's let B be the business majors, and let's let N be the nursing majors. This can help you out in terms of checking your equations and your answers. So from here, the next thing we want to do is kind of look back at the given information and see what we have here. The first thing that we have is the median starting salary of nursing exceeds that of business by $10,000. So what we have is, I'm going to just write this and take out all the crap and make it a little bit easier to read. So what we have is nursing exceeds business by 10,000. And I'm just going to leave it as a 10. I don't want to add in more zeros. That'll make the numbers a lot larger. Will make the problem a little bit harder to solve. So nursing exceeds business by 10. So exceeds, what do you think that that word means? Exceeds tells me I want to add. I want to make it bigger. So now the question is, do I want n equals b plus 10, or do I want b equals n plus 10? Well, for this one, I'm going to go with n equals b plus 10. Who makes more, nursing or business majors? Nursing makes more. What we want to do is take the amount that the business majors make and add 10,000 onto it to figure out the nursing. The second one that we have is combined their median starting salaries are 96,000. So if we say combined, what does that imply that we should do? When I hear combined, that makes me think that we should be adding them. So what I'm going to do is, this is going to be n plus b equals 96. Okay, so we have our model. We're going to take these two equations here. N equals b plus 10 and n plus b equals 96. Now that we have our system of equations, we can go ahead and solve this. So I want to use substitution method. I'm going to take my b plus 10 and plug it in for n in the other equation. So if we do this, we get b plus 10 plus b equals 96. We can combine our like terms. We have 2b's plus 10 equals 96. From there, we can subtract 10 from both sides, and we get 2b equals 86. To finish this off, I want to divide by 2, and we are left with b equals 43. Okay, so that's all great. Now we need to go ahead and find n. Well, n is equal to b plus 10. So we get n is equal to 43 plus 10. So n is equal to 53. Okay, so that takes care of solving the system. So the last thing we need is our interpret and our units. Keep in mind, interpret, you just need to write a sentence, maybe two. Does not need to be a thesis. Does not need to be a doctoral dissertation. Just a statement answering the original question. So we can go ahead and say that nursing majors make 53,000, since n was 53, and business majors make 43,000. Though I didn't include median starting salaries with bachelor's degrees, this does answer the question. It identifies what number goes with which variable or which unknown. And so that takes care of example A. So let's go on to the next example. We have a rectangular soccer field is twice as long as it is wide. If the perimeter is 300 yards, what are the field dimensions? So one thing to note here is that we are talking about a rectangle. And so when we talk rectangles and perimeter, we are talking about length and width. You also have the words in here long, wide. And so my variables that I'm going to use is I'm going to let L be the length, and I'm going to let W be the width. For this problem, I'm going to go ahead and set up a picture. So we have a perimeter, or a rectangle. We have the perimeter is 300. We have W's, we have lengths. And so now what I want to do is translate the statement. So we have, first off, that the field is twice as long as it is wide. So one thing to note here is, okay, so how are we going to translate that? Well, in order to translate that, what we want is, I know twice means multiply by 2. So do I want W equals 2L, or do I want L equals 2W? Well, which one should be larger? Should it be the width or the length? Well, if it is twice as long as it is wide, that tells me that I want my length to be bigger than my width. So W equals 2L, that is not the one I want to go with, because if you do that, if you multiply the length by 2, then your width is always going to be larger. So the one that I want to go with is L equals 2W. That is our first equation. Now, the second equation is a formula. It says the perimeter is 300 yards. So if my perimeter is 300 yards, I need my perimeter formula. So remember that the perimeter formula is P equals 2L plus 2W, and I want to plug 300 in for P. So now we have our mathematical model. From here, we're going to go ahead and solve using substitution method. So I'm going to take 2W, and I want to replace L in my perimeter formula with 2W. If we do that, we get 300 plus equals 2 times 2W plus 2W. We want to go ahead and multiply to get rid of the parentheses, so we get 300 equals 4w plus 2w. And if we combine our like terms, we get 300 equals 6w. Finally, I can divide by 6, and we get 50 equals w. So now what is the length? We're going to go ahead and take this, plug it back into our formula for L, or the perimeter formula, it doesn't matter. And if we do that, we get L equals 2 times 50. So L is equal to 100. Finally, does the answer make sense? Does it make sense that our width is 50 and our length is 100? Yes, this is, our length is larger than our width. So now we want to go ahead and interpret our answer. So you can say things like the length is 100 yards. The width is 50 yards. And we're done. This is the first of the classic problems for systems of equations involving applications, is the perimeter of a rectangle. So hopefully this one makes sense. I went ahead and did this one in terms of the twice as long as it is wide, just because that's a little harder to interpret, and I wanted to make sure that we were clear on that. Okay, so now let's talk about some other classic application problems. Some other classic ones involve angles. So there's 3 different things that we're going to want to know about angles. The first one is the 3 angles of a triangle add to 100 degrees. Hopefully everyone's aware of that one. The second one we have is 2 angles are called complementary if they add to 90 degrees. And the last one, 2 angles are supplementary if they add to 180 degrees. All right, so let's go ahead and look at some problems involving angles. This problem, in a triangle, we have a triangle problem. This problem, I will let you know, is the only problem that we will look at that has 3 unknowns. When you get into higher level math classes, you may see other ones, but this is all we're going to look at. And in order to solve a problem having 3 unknowns, we are going to have to use substitution method on this one. So we have, in a triangle, the measure of the first angle is twice the measure of the second, and the measure of the third angle is 20 degrees less than the second. We want to know what is the measure of each angle. So the first thing that I note here is that I have a first angle, a second angle, and a third angle. So we do need 3 variables. I'm going to go ahead and just use x, y, and z. I'm going to let x be the first, y be the second, and z be the third. All right, so now let's see what else we can do. It says the first angle is twice the measure of the second. So let's go ahead and translate that. It says the first is twice the second. So remember that first we said was x, second we said was y, so we have x is twice y. Now note that this is a little bit different than the previous example. We're not saying twice as large, we're just saying it's twice. So we do have x equals 2 times y. The second statement that we have is the measure of the third angle is 20 degrees less than the second angle. So if we have the third is 20 less than the second, remember that third we said was z and second was y. So we have z is 20 less than y. We have the word is here, so I know that that is equals. And we do have less than. Remember that less than was a reverse order phrase. So I actually want this to be y minus 20, not 20 minus y. Remember that we do need to flip these around. So we get z equals y minus 20. All right, so those are two of the equations. Now remember that I said you have to have however many unknowns you have, that's how many equations you need. So what is the third equation? Well, the third equation is, it's a triangle. So my third equation is I want to add up the three angles, and this is equal to 180. So my system of equations is x plus y plus z equals 180, x equals 2y, and z equals y minus 20. Okay, hopefully we're okay up to that point. All right, so now the next thing that we want to do is to solve the system. So this is using substitution method. So in order to solve the system, I'm going to take 2y and plug it in for x. I'm also going to take y minus 20 and plug it in for z into my triangle equation. So if we replace x with 2y, we still have plus y, and we have plus y minus 20 equals 180. So hopefully you saw what I did there. All we did was we took 2y and replaced x. We don't have anything to plug in for y, so we're going to keep it. And we're going to take y minus 20 and replace z. We can go ahead and now solve this. The first thing I want to do is combine my like terms. So I get 2y, y, and y. If we add those, we get 4y. I'm going to bring down my minus 20, and I'm going to bring down equals 180. From here, in order to solve this, this is now a very basic equation. We want to add 20 to both sides. We are left with 4y equals 200. And if we divide by 4, we get y equals 50. So there is one of the angles. In order to find the other angles, what we're going to do is plug it back into each one of these little equations. So for instance, x, I'm going to get x equals 2 times 50, which is equal to 100. For my z equation, I get z equals 50 minus 20 equals 30. And so there are my other values. So now we just need to interpret. We have the three angles. The three angles of the triangle are 100 degrees, don't forget your units, 50 degrees, and 30 degrees. And there is that problem. Again, this is going to be the only one that we will look at that has three unknowns, but hopefully you can kind of follow along and see how this works. Our final example that we want to look at is we're going to look at an example of complementary. So remember that complementary, let's read through the problem. We have two angles are complementary. The first is 40 degrees less than 4 times the second. So here we have a first angle and a second angle. We want to find the measure of each of these angles. So I'm going to go ahead and let x be the first, and I'm going to let y be the second. Okay, so now the next thing that we want to do is go ahead and translate the other part of this. So we have the first is 40 degrees less than 4 times the second. So if we were to write that out, we have the first is 40 less than 4 times the second. Okay, so remember that first was x, second was y. Right here we have our equal sign. Remember that less than is a reverse order phrase. And so we want this to be not 40 minus, but something minus 40. And the something minus 40 is going to be the 4 times y. So we get x equals 4y minus 40. Our second equation is the fact that these angles are complementary. So remember that complementary means that they add to 90. So now we have our system of equations. So I'm going to go ahead and solve using substitution. So I want to take my 4y minus 40 and plug it in for x. If we do that, we get 4y minus 40 plus y equals 90. Hopefully you followed along with that. Now that we have our equation with just one variable, we can go ahead and solve using our techniques for solving equations. We want to combine like terms for y and y. Gives me 5y minus the 40, we're going to keep it, equals 90. I can add 40 to both sides to get my y term by itself. We get 5y equals 130. And finally, if we divide by 5, we get y equals 26. So there is the first, or actually the second angle. So now let's find the first angle. Now one thing to note here is that it does not matter which one you plug it into. If you want to plug it into the first equation, that's okay. But for me, it's a little bit easier, a little bit less to do if we plug it into the second equation. So we get x plus 26 equals 90. If we subtract 26 from both sides, we get x equals 64. Okay, finally, we want to go ahead and interpret the results. So what we have here is the measure of the two angles are 64 degrees and 26 degrees. And we're done. So now, take a little bit of time and see what you can do with the following problems. Translate to a mathematical model, interpret your results, and include correct units. When you are done, make sure that you bring these to class, as well as any questions that you have over any of the problems in the lecture or with these problems in particular. Please take a moment to pause the presentation so that you can go ahead and work on these problems before continuing on to the next slide. Once you are done, answer the following questions and bring your answers to class. How confident are you with the material presented? What from this section needs to be explained further? And how much more practice do you need to be comfortable with the topic?